Alright, hello everybody. So today we're going to discuss lesson 7.1. So we are in chapter 7 and we're going to talk about linear systems. And this specific lesson will be about solving linear systems by graphing. So again, this is lesson 7.1. And definitely I'm going to give you some main ideas that you have to write down. So let's switch now from the textbook, what it looks like, the lesson, to the notes that you must take along with me and the video. So the lesson is called again Solve Linear Systems by Graphing. I want to kind of emphasize on a couple definitions here. First of all, what is system of linear equations? Well, in order to have a system, we need to have two or more linear equations. So in our cases, most of the time, you will see two equations in the system. When you reach to Algebra 2 at the high school, you may see longer systems with more equations, but for now, we want to make sure we always work with two. And again, to be a system, the equations must be two or more. The solution of system of linear equations, on the other hand, is an order pair that is true for each equation in the system. So hopefully you guys remember when we worked with equations and there was given for us a point with different numbers, one pair, then our job was to substitute x and y and see if the left side of the equation is equal to the right side of the equation. And if the statement is true, then we have solution to the equation. We will do the same thing here, but because it's system, now instead of checking only one equation, we will have to check two equations. Before we do this, let's go ahead and learn how to graph systems of equations in one particular graph. So first example, we have given systems of equations, and I like to write a line. The line shows me that those two equations are somehow connected. That's why we call them systems. So in order to graph both equations, we will need a graph coordinate plane, and we will graph each equation independently. Now everybody knows, I'm going to just draw my x and y axis. So this will be my y axis. This will be my x axis here. And you guys know that in order to graph an equation, we need to know y-intercept, which will be the first point on the graph, and we need to know the slope. So from this equation, I can write over here that the slope is equal to 1. So it's always the number in front of x, in this case is 1, and b will be -7. Another reminder, y-intercept or b has coordinates. X is always 0 and y is -7. So now we're going to start with this point when x is 0 and y is -7. So I have 2, 4, 6, and -7 will be actually somewhere here. Well, let's go by 2, scale of 2. So I would say -2, -4. No, I'm gonna change that. I will move my y actually coordinate a little bit to the right because I want to have a good looking graph. It's really important the graph to be well precise. So you don't need to erase anything, you just need to make sure that you have enough space to the left. Okay, so let's start. This is the original. 0 for x and y -7 will be down here. 2, 4, 6, -7 is right here. So this is first point on the graph. Okay. Now, if I start with b, with first point, -7 on y-axis, then I have to apply the slope. 1 over 1, 1 over 1. So it will be 1 over 1, 1 over 1, positive slope, 1 over 1, 1 over 1, 1 over 1, 1 over 1, and we can keep going. It's also very important that you plot all the points. When you have given graph, make sure you put as many points as you can over the graph, because we don't know when and where the other line will intersect the first line, and then we can talk about the solutions of the system. So first thing, make sure you always plot a lot of points on the graph just by applying the slope. So that will be my first line on this graph. Second line will be second equation. Slope of the second equation is -1/4 and b is -2. So b -2 is right here, and we have negative slope. Negative slope means we go 1 down and 4 to the right. 1 down and 4 to the right. So look at this. If I connect those 3 points, and I will turn around my paper a little bit because I would like you to see. So this is the line that crosses. That will be the first equation of the line. This will be the second equation of the line. Once you graph both equations, you will see there is one intersecting point. Now, this is the main thing about today's lesson. This intersecting point, it's called one solution. One solution to the system. So this linear system of those two equations have one solution, and the solution is the intersecting point of the two lines. And with that, we will be done. So pause the video, take a moment, complete the graph in your notes, and we'll continue with next one. Okay, so if you're done with the graph, I would like you to work on the second graph. So the second graph here will be based on the second problem we have given. So what I'm gonna do, I will cover this. We'll use the graph paper to work on this second problem. So second problem, we have another equation where it says y equals x minus 5, so the slope is equal to 1, y-intercept is -5. What do we need? We need x and y coordinates to start with. So this is x, this is y. And I will begin with my first graph, or first equation. b -5 means 1, 2, 3, 4, 5. Here is -5. For b, or y-intercept, that will be the first point on the graph. And then we have another slope of 1 to apply. So 1 over 1, 1 over 1, 1 over 1, 1 over 1, 1 over 1. You gotta keep going. You need a lot of points here because, again, you don't know where the two lines will intersect, so you want to make sure you have all the points and the solution if there is one. So once you have your points, you connect all the points with a long line, and that will be the first equation on the graph. Now let's take a look at the second equation. M is -3 and b is +3. So b +3 I have right here. This is 3 for b, for y-intercept. And m -3 means we go 3 blocks down, 1 to the right. 3 blocks down, 1 to the right. 3 blocks down, 1 to the right. I'm gonna stop here because I already seen when I draw a line that this will be my intersecting point. So when we connect those points of the second line of the equation, everybody can see that this point is the intersecting point, and again we have one solution to the system. So that will be your answer here for this example. Alright, so I know the graphs take some time, so please rewatch it, follow my steps. If it goes too fast, pause it, wait, and continue after. I'm moving forward, so let's take a look of next example on the back. So next example on the back, we have to solve the linear system. There are two things here to consider. First one will be the first equation, which is already given for me in y-intercept form, y equals 3/5 x. So I can write down that the slope here is 3/5, and by now I think you will be right if you say that y-intercept is 0, because this is the same thing as plus 0, right? If we're adding nothing to this, this stays the same, it doesn't change. So b will be 0. Which means if I draw a line and I graph my axis, x and y axis, right here, x and y, first point for this equation will be at the origin, because this is b. B is 0 here for y axis. Then we're going to have 3/5 and another 3/5. And I will do another 3/5 to the other direction, the opposite direction, another 3/5. So those are all points from the first equation graph, and we connect those. Now let's take a look at the second equation. Just look at the equation and think about, by looking at this equation, can you tell which one is the slope in b? No, we can't. So as usual, what we do, we solve the equation for y. So let's go ahead and solve this equation for y. It's going to be plus 3x on each side. Those two cancel. And we have 5y is equal to 3x minus 25. Next step will be to divide by 5, because again, you want to cancel. You want y to be itself and slope intercept form. So 3/5 x minus 25 divided by 5 will be 5. So that is the equation we're looking for the second line. And m is 3/5 and b is equal to -5. Awesome. So let's find b first, -5. 2, 4, 5. This will be the first point. Here's b -5. And let's go ahead and apply the slope. 3/5. 3/5. If I go down 3/5, that will be my next point. Well, what is happening now, we will connect those points, and I want you to look one thing here. Do you see any intersecting point between those two lines? No, but what you will conclude by looking the graph? Well, this is what we call parallel lines. The two lines are parallel, and the reason for that is because they have, both parallel lines, they have exactly the same slopes. So if the two lines, line 1 and line 2, have exactly the same slope of m equals 3/5 and m equals 3/5, we have parallel lines, and the answer here is no solution. We don't have solution for this system because the two lines, they never intersect. So since the parallel lines never intersect based on the definition, we know that this system has no solution. All right, so that was the third example I wanted to show with you, and number 4 and 5 will be just checking and making sure if the point that is given is a solution to the system. So again, not just solution to one of the equations, but it has to be solution to both equations from the system. So let's call this equation A and equation B. Equation A has 2x minus 3y equals 4. So I'm going to substitute my x and y coordinates from this point over here. That will be 2 times x is 5 minus 3 times 2 equals 4. Once you substitute your x and y coordinates, then you gotta solve the equation. See what you get in the left and what you have on the right, and if they are equal to each other. So 2 times 5 is 10, remember PEMDAS rule, and -3 times 2 is -6 equals 4. 10 minus 6, 4 equals 4. Alright, check mark for the first one. But we can't tell yet if this is solution because we have to do another equation from the system, B. So we will do the same thing. 2x plus 8y equals 11. x and y, I have 2 times x is 5 plus 8, y is 2 equals 11. Solving those equations, 2 times 5 is 10 plus 8 times 2 is 16 equals 11. So 10 plus 16 is 26 equals 11. Those two are not equal. So your final answer here is no solution. Again, this point, this ordered pair is not solution to the system. It's point somewhere in the graph, but not intersecting point of those two equation lines. All right, next problem. What do we have here? We have equation A and B. So A is x plus y equals -2. In this case, x is -3, y is 1. So -3 plus 1 equals -2. -2 is equal to -2, check mark. Awesome. Equation B, on the other hand, we have x plus 5y equals 2. Okay, so this is x, not 5. X plus 5y equals 2. So x is -3 plus 5 times 1 equals 2. -3 plus 5 times 1 is 5 equals 2. Well, this is 2 equals 2. Check mark. Both of those are true statements. So if both equations are true statements, then we can say that the solution for this system is order pair -3 and 1. With that, we will end this lesson, video lesson. And before I finalize everything, I just want to do a quick summary of what we just discussed. So we begin with solving linear systems by graphing. We learned that in order to have a linear system, we need at least two equations. When you have given two equations, your job is to find out what the slope and y-intercept is. Then you graph first line on the graph. Next thing, you find out what is the slope and y-intercept for the second equation. You graph the second line. When the two lines intersect at one point, this point or this order pair is what we call solution to the system. It's one solution to the system. Second problem was very similar to the first one. We did exactly the same thing. Then I showed you another example. If we have a system and one of the equations is not in slope-intercept form, you have to work and calculate that and make it look like y-intercept form equation, y equals, by solving the equation for y. Write down what the slope and y-intercept are equal to, and then graph it. So in this case, we had two lines that are parallel to each other. They do not intersect, so the answer is no solution. So all of those 3-4 examples that we did at the beginning were by graphing. So we did find the solutions by graphing. Those examples, they do not require graphing. They're just asking if you know already this point that we will assume is the crossing point at the beginning. If we know that, and if we know the system, can we tell if this point is part of the solution, our solution to the system? And the answer will be fine when we are substituting x and y coordinates into the equation and see if we have a true statement or not. So in first case, we did not have. The second case, we found the solution because both statements were true. Well, thank you for watching. Let me know if you have questions, and we will move on to the next thing. So have a great day, everybody.